Platforms like GitHub are already moving to train their models on hosted data by default. Currently, the market normalizes scraping and training on human work at zero cost to the AI developer. Individual creators lack the infrastructure to fight these automated pipelines. Without an active enforcement mechanism, their work is treated as a public resource for ingestion. To regain leverage, the market must shift to a deny-by-default access posture. If the training rights aren't purchased, the data remains inaccessible to the scraper. This requires an API-level compliance layer. By embedding watermarks into the content, creators can bundle their intellectual property for collective enterprise licensing. Without a technical mechanism to create friction, the economic value of high-quality human training data will continue its trend toward zero. Metastamp Pockets is the infrastructure designed to solve this. It operates as the ASCA for the AI age, serving as a central clearinghouse for rights. The system provides standardized train and license terms that are attached directly to a creator's work, defining exactly how that data can be used. It also implements a metadata taxonomy during onboarding. This ensures that style and character consistency are maintained and attributed correctly when the AI ingests the catalog. By standardizing these rights and terms, Pockets allows creators to pool their assets. This scale is necessary to negotiate significant licensing deals with large enterprises. This moves the creator from a position of individual vulnerability to collective, enforceable pricing power. Enforcement begins at the network layer. A technical gate protects a creator's corpus, monitoring incoming agent requests. When an agent attempts to scrape the content, an embedded watermark identifier acts as the trigger for the system. Once the watermark is detected, the system issues an HTTP 402 status code. This payment required message rejects the unauthorized request and stops the ingest. These strict access controls are designed to break legacy data harvesting. The agent cannot proceed with training until the technical requirement for payment is met. Technical compliance is the prerequisite for any economic model. Without a physical block, training rights remain a suggestion rather than a requirement. The licensing problem is growing as AI agents transition from scrape and forget behavior to persistent context memory. In the legacy model on the left, an LLM makes a discrete call every time it needs data. Each scrape is a billable microtransaction. Modern stateful agents on the right function differently. They pull the data once and retain it indefinitely within their context window, meaning they never need to re-scrape that same information. This architectural shift means that per-scrape pricing models eventually drop to zero. If the agent only pulls the data once, the recurring revenue model breaks. Licensing must therefore pivot to annual enterprise contracts. This ensures creators are paid for the ongoing value of the knowledge the agent retains. Persistent memory is actually a massive revenue multiplier, provided the infrastructure exists to charge for that long-term retention. A machine that remembers forever requires a financial model built around access to that memory, rather than the act of fetching it. Enterprises are already preparing to pay for this infrastructure. Data from McKinsey indicates that leaders are seeing a 20% EBITDA uplift by building their business around AI agents. Because agentic engineering offers such rapid break-evens, often in just 1 to 2 years, companies are prioritizing the speed of deployment over the cost of data. Salesforce is a primary example. They are moving to headless systems, where agents bypass traditional interfaces to access data directly through the Model Context Protocol. Even at the highest levels of tech leadership, executives are acknowledging that agent operations will eventually require formal licensing agreements. However, a flat-rate model for data is inefficient. Training data has a pricing hierarchy. Highly distinct and recognizable IP, such as footage of Tom Cruise, carries significantly more market weight than random generic B-roll. Pockets uses tiered pricing based on popularity and usage, mirroring the models used by organizations like Getty Images. Style cohesion creates recognizable catalogs, and those highly recognizable catalogs provide the ultimate leverage when negotiating with major enterprise buyers. To reach a global scale, the system must move beyond cloud servers and onto the devices themselves. Qualcomm's vision for AI agents everywhere involves running these models locally on Snapdragon processors. This local execution happens at a massive mobile scale, targeting millions of Android devices. But hardware manufacturers have a problem. They currently lack a way to manage content rights for agents running natively on the chip. Since Pockets runs on the same model context protocol that Qualcomm already supports, it provides the missing licensing layer for on-device AI. While network layer gates block cloud scrappers, hardware integration is necessary to manage data rights during offline, local processing. By pre-installing these creator rails at the chip level, the licensing logic remains active regardless of where the agent is running or if it's connected to a central server. This infrastructure is already being tested in the real world, with Darman as founding partner. The test parameters are quite substantial, utilizing a library of over 3 million videos that have generated billions of views. Studio heads have explicitly stated they will not build this complex infrastructure themselves. They need an external standard they can simply plug into. This proof of concept is designed to demonstrate that the Pockets technical layer can handle a massive, high-traffic content library. Successfully managing a catalog of this scale establishes the technical baseline that other major studios will need to adopt to secure their own rights. The model is now complete. The Darman POC proves the technology, Qualcomm provides the distribution, and annual contracts provide the revenue. This creates a self-reinforcing network effect. As more data is secured, more enterprise revenue flows in, which then attracts more creators to the system. As the volume of participants grows, the value of the network becomes mathematically indispensable to any AI company that requires high-quality, recognizable training data. Metastamp Pockets provides the essential technical architecture required to convert data from a free resource into a protected, licensed commodity.